All right, hello, Algebra 2 class. I hope you had a great Christmas break, and I hope it works out well for you to watch the video and then be able to go and do your assignment on your own. So I'm going to be working through the next 4 lessons, and then I'll give you the assignment at the end, and then you can finish those up, and I'll see you next Monday. So we're going to start with lesson 64. And I'll just work a couple of practice questions at the beginning. So the first one is about complex fractions. B plus 1 over z plus 2m. So your job is to try to get the fractions out of the fraction and try to make it look more simple at the end. So we're going to start here, and we're going to take that mixed number and get a common denominator. So we'll just bring the b down, bring the 1 down, and then our common denominator will be the z, and the 1 is already over the z, and we'll need to add, multiply a z there by the 2m. And now we have a numerator, and our denominator has a fraction in it, so we're going to get rid of that. So your book likes to take the bottom and flip it over and multiply it on the top and the bottom, and that will work every time. But if you want a little less writing, all you really need to do is take that denominator and multiply it 1 over the other, which is just multiplying the fraction times 1. And when you do that, this and this can cross out, and you're left with 1 times z, which is z, over 1 plus 2mz. Now, we have 1 step left. We still have a mixed number that we're going to get a common denominator for. And so our common denominator will be, we'll go this way, will be the 1 plus 2mz. So we'll need to multiply the b times the 1 plus 2mz and add this z to it, which is already has that denominator. And then I'd like for you to do one last step and just go ahead and multiply that b in. So our final answer for this one will be b plus 2mzb plus z over 1 plus 2mz. So that's how you take a complex fraction and simplify it. So what I'd like to do is do one more example similar to that one. All right, this one starts with s over z plus 3 over 5 plus 2s over z. All right, so again, we'll start in the same place we did last time. We'll start on the very bottom of that fraction, and we'll get a common denominator. So we'll just bring our s over z down, and we'll get a common denominator, z, and we'll multiply the 5 by the z and add the 2s. Next, we'll get rid of that fraction in the bottom by multiplying by z. It won't always be a z, it just happened to be in the last 2 examples. Then we can reduce those. Now we have s over z plus 3z over 5z plus 2s. So now we just have 2 fractions that we need to add together. So you need to get a common denominator. And what I would do here is just pick one of each, and that's your new common denominator. We'll go this direction. So we'll pick the z, and I'm going to put the 5z plus 2s in parentheses because there's a plus sign. And then we'll need to take the s already has the z, but we need to multiply the s by the 5z plus 2s. And the 3z already has this one, so all we need to do is take the 3z times the z. And then we'll just multiply out the numerator. So we have 5sz plus 2s squared plus 3z squared. And for some reason, most of the time in your book, they don't multiply out the denominator. They do multiply out the top, but not the bottom. So we can do that, and that'll be our final answer. All right, in this lesson, they are going to also teach you how to do some multiplying with some i's. So we'll do a couple of examples with that. So our question is I to the 4th minus 5i cubed minus 3 times the square root of negative 3 times the square root of negative 5. So just as a little review, the I, remember, is actually the square root of a negative 1, which is an imaginary number. And when we square the I and we square the square root of negative 1, we have a nice tool to use to take an imaginary number and make it into a real number. So we're going to use this tool to try to bring all of these higher exponents down to I squared. So the I to the 4th would be I squared times I squared, which is negative 1 times negative 1, which is 1. And the I cubed would be I squared times I. And so, remember, for each I squared, we have a negative 1, so that would be negative 1 times negative 5. So that makes that positive 5, and we still have the I. Now over here, we have the I hidden underneath the square root sign. And this would be the same thing as the square root of negative 1 times the square root of 3. And so what I'll do is our famous popping our I out of the square root sign. So the square root of negative 1 part is the I, but we still have the square root of 3. And we'll pop the I out of this one also. And so now it looks like I've made a mess, but I've actually made it simpler, because all I need to do now is I have I times I. Well, that's an I squared, and that's a negative 1. So I can take my minus 3 and take it times negative 1 and make it plus 3. And I can take what's under the square root sign and multiply those together. So I have the square root of 15. And I believe that would be my final answer. So that's the answer to this one. And I'll try another example that is actually multiplying two of these. We have 3 plus 5i, and we have 4 minus 5i. And they just want us to multiply those together. So you're going to do what you would normally do and use your FOIL method. So we'll multiply our first terms, 3 times 4. We'll multiply our outside terms, negative 5i times 3, which is negative 15i. We'll multiply our inside terms, which would be 20i. And we'll multiply our last terms. So you can multiply the 5 times 5, or 5 times negative 5, which would be negative 25. And then we multiply the I times I, which is I squared. So you just have one small step of just combining anything that's like. Now remember here, I squared is a negative 1. So this actually makes this whole term plus 25. So I could take 12 plus 25 and get 37. And then I could take my imaginary part and take negative 15 plus 20 and get 5i. And so 37 plus 5i would be my final answer on that one. All right, and that is the end of lesson 64. So next we'll move to lesson 65. All right, in lesson 65, we have one question, and they're going to start you with a whole bunch of missing letters, and they don't tell you what they are. They just say it's RP, TP equals 288, but I think we all know what that's going to turn into later, right? Rate times time, probably, a distance question. We're also given that RC, TC is 108. We also know that RP equals 3RC. And we know TC, plus TP equals 12. And so the question asks you to use what they call advanced substitution to find out all these missing letters. So you're just going to set it up like a regular substitution question. I decided to, since I had this RP equals 3RC, I decided to use my 3RC in my substitution. So I'm going to go ahead and say that the 3RC, which is an RP, I can take that one and substitute it in there. And next I need a TP, and I can substitute and say that TP here would be 12 minus TC. So I'll put that in my equation, 12 minus TC. And so the RP, which is 3RC, and the TP, which is 12 minus TC, should equal 288. So you just kind of have to keep yourself a little organized and figure out where you're substituting. Now we're going to just multiply this in. So that would be 36 RC minus 3 RC TC equals 288. Now we have one equation, but we actually have two missing letters. But the fun part of this one, this is the advanced part, is that RCTC we actually know. That is 108. So I could substitute 108 where our missing letters are. And now I magically have one equation with one missing letter, and now I'm home free. I should be able to solve for my RC pretty easily. I have 36 RC, and if I took, if I multiplied this and then added it to the 288, I would get 612 divided by my 36, and RC is a nice, neat 17. A lot of times these questions will turn out neatly, so you know you've done them right. Now I'm supposed to find all the letters. So if I have RC is 17, then I could go back up here and say, substitute that back in here and say 17 TC equals 108. And TC is 6.4. And now I could find a TP, because 6.4 plus TP equals 12. So TP is 12 minus 6.4, which is 5.6. And that's 1, 2, 3, and I must be missing RP. And RP is 3 times RC, so I could take 3 times 17 and get RP, and that makes RP 51. And I've solved for all my letters. So that is what we call advanced substitution. I guess the advanced part is just remembering that when you have those two letters together and you're given that answer in the question, that you can substitute that in and be able to find the rest of your letters. So in lesson 65, you're just given a set of missing letters and you need to find their value. All right, so now we're ready to move on to lesson 66. And we'll be doing two different things in lesson 66. The first one are questions that look like this. 1 over z minus 2 minus 3m over negative z plus 2. And so, of course, you want to be able to add your fractions together, but you need common denominators, and the denominators are almost the same. Z minus 2 is so close to negative z plus 2. Our only problem is this negative sign. So what we're going to do is we're just going to manipulate it a little bit. We're going to take the negative out of the denominator and shift it to the top of the fraction. So if I were to factor out the negative, both of these would change signs, and I magically have my z minus 2, which is what I was looking for to begin with. And then I just need to take the negative and shift it up there to the 3m. So what I have here then is 1 over z minus 2, and if I shift the negative up here, then I have minus a negative 3m, which is plus 3m, and I have my z minus 2. Now I have common denominators, and I can just write my answer as 1 plus 3m over z minus 2. So I hope those won't give you too many problems. You just need to take the bottom, factor out the negative, shift it to the top, and combine your fractions together. All right, the second part of this lesson deals with what we call 30, 60, 90 triangles. And this is going to pop up quite a bit, and if you can just learn this little method to solving the missing sides, then I really think it'll save you a lot of time in the end. So a 30, 60, 90 triangle is just what it says. Those are the angle measures of the triangle. So we'll set up a triangle with a 90-degree angle, and we're going to call this our 60-degree angle, and we'll call that our 30-degree angle. And there's something interesting about the sides of a 30, 60, 90 triangle. If you start out with a hypotenuse of 2, then one of the other sides is half that, which is a 1, and the other side is a square root of 3, if you were to use the Pythagorean theorem. And all 30, 60, 90 triangles are in this ratio. So you can set up a ratio between the two triangles, and if you can memorize this one, then you can solve any 30, 60, 90 triangle. So one way to remember these numbers, because I really want you to memorize this triangle, one way you may use to memorize it is just picture a triangle with all the same sides and all the same angles, 60-degree angles, with side 2. And if you were to cut this triangle in half and pull it out here, you still have this 60. When you cut it in half, this one is 30, and this one has become a 90. The hypotenuse is still 2, but this side has now been cut in half, and it's your 1. And then if you needed to find the other side, you could use the Pythagorean theorem and say 1 squared plus side squared equals 2 squared, and you would end up with the square root of 3. So however it makes it easier to remember, this triangle. If you want to start here and cut it in half and do all that work, you can, or you can just memorize the side lengths of this special triangle. Now, let's look at, I'm going to begin calling these sides by their name. If we looked at the longest side, which is the hypotenuse, that shouldn't be a new word for you. The hypotenuse of the triangle is always the longest side. It's always the side opposite the 90-degree angle. Now, if we start with the little baby angle, the 30-degree angle, and you go across from it, its side opposite is called the short side. And the other side across from the 60-degree angle is called the long side. So we have short, long, and hypotenuse. Now, let's see how we can use this triangle to solve another triangle with the same angle measures. So we have the same 90-degree angle, we have a 30 and a 60, and let's say we're given this side, but we don't know this side or that side. So we want to try to find it. Now, in your book, they're going to set up a scale factor and figure it out with a fraction with the scale factor. And that's fine, that works every time. But if you want a little shortcut, what I like to do is I like to see which side is the 5. Well, the 5 is opposite the smallest angle, so it's my short side. Now, if you look at the short side, the hypotenuse is twice the length of the short side, because 2 is 1 times 2. So if we took 5 times 2, we would automatically have the hypotenuse. Just by looking at the triangle, figuring out this is the short side, hypotenuse is twice. And then let's again start with the short side and compare it to the long side. If I took this short side and multiplied it times the square root of 3, I would have the long side of the triangle. So let's take 5 times the square root of 3, and we now have the long side of the triangle. And that's how the easiest way, I think, to solve a 30, 60, 90 triangle using the model triangle here with these sides. So all we did was we took the short side, took it times 2 and got the hypotenuse, took it times the square root of 3 and got the long side. Now, this is the easiest kind to solve because we were actually given the short side, and the short side is kind of our hinge for figuring out the other sides. So let's see if we could take a triangle where we don't know the short side and try to figure out the other lengths. So we're given, again, a 30, 60, 90. And this time we know this side, but we don't know this side or this side. So your job is to find A and B. So the first thing you need to do is look at the number given, the length given, and look at the other side, and that's opposite the 60-degree angle. So that must be our long side. So we're going to start with the long side and try to get the short side. So remember when we went from short to long, we multiplied times the square root of 3. So to go in the other direction, we could take the long side and divide it by square root of 3, and we'll have the short side. So let's take our 7 and just divide it by root 3. And as we know, it's bad math manners to have a square root in the bottom of a fraction. So we need to get rid of that root just by simply multiplying it by root 3 over root 3. And my short side then, A, should be the 7 root 3 over the square root of 9, which is a 3. And they want you to leave your answers with the square root in it. Don't give me a decimal, and don't try to multiply it out or anything. Just leave the root 3 in your answer. So all I did to get the short side then was take 7 and divide it by root 3. Now I have my short side. So my hypotenuse should be twice as long as the short side. So all we need to do is take this times 2. So 7 times 2 would be 14. Go ahead and leave your root 3 over 3, and that is your hypotenuse. So for these kind, you don't need the Pythagorean theorem, and you don't need to do a long equation. If you can just memorize this basic triangle, and then either multiply or divide by your root 3 and your 2, then you can solve your 30, 60, 90 triangles. So I hope you'll give that a good try this week. These are going to come up a lot. They really like to put these on the ACT test because if you know the 30, 60, 90 rule, then you could really quickly solve those kinds of questions. So now we only have one lesson left, which is lesson 67. All right, lesson 67. This lesson has everything to do with getting those pesky square roots out of the bottom of fractions. And the way we're going to do that is we're going to use something that we call the conjugate. Conjugate is a word I'd like you to remember, and if you can remember it at the right time on a test, you could get some extra credit for that. What the conjugate is if we have two numbers that are being added together, then its conjugate is the exact same first number or letter, but the opposite sign of the second. And the reason it's useful is that if I were to multiply these two together, they're special because if I were to FOIL them out and multiply them, the outside term and the inside term cancel each other out. Because we would have negative AB plus AB, and the middle terms would always cross out. And so this is going to be helpful in getting this square root out of the bottom of our fraction later. So you just need to be able to identify, like if this was in your denominator, negative 4 plus root 3, then you would need to multiply that by its conjugate to get rid of those middle terms. And so you keep the same negative 4, but you switch the sign of the second term. So these two would be conjugates of each other. So let's see what your questions actually look like. And they're actually pretty short. You start with 1 over negative 3 plus root 7. And so the little math rule is that it's like bad manners to have a square root in the bottom of a fraction. So your job is to always get rid of the bad manners in the question. So what we want to do is we want to take this fraction and multiply it by the conjugate of negative 3 plus the square root of 7. So its conjugate would be negative 3 minus the square root of 7. And anything you multiply on the bottom, you have to multiply on the top also, so it doesn't change the value of the question, because one thing on top of another is a 1. So what I'm going to do is multiply the numerators, 1 times my negative 3 minus root 7, and then multiply my denominators by FOILing them out. So if I FOILed it, I would have negative 3 times negative 3, which is 9. And remember, the magic of the conjugate is that if I took negative root 7 times negative 3, I would have positive 3 root 7. And then if I multiplied the middles, I would have negative 3 times root 7, which is negative 3 root 7. So a positive 3 root 7 plus a negative 3 root 7 is 0. So my middle terms cancel out, and all I need to do is multiply my last terms, which would be negative square root of 49, which is negative 7. Well, look what I've done. Magically, my radicals have disappeared out of the denominator, and it's just fine for some reason to have one in the top but not the bottom. So you can leave your root 7 in the top. 9 minus 7 is 2, and that is your answer. That's all you have to do for that kind of question. So I'd like to just do one more of those as a practice, and we'll be finished. All right, so in this next one, I'm going to use the middle of the board. All right, so my question is 5 over 3 root 2 plus the square root of 3. All right, so you think to yourself, oh, look, I have a square root in the bottom of the fraction. I need to multiply by the conjugate. So the conjugate is 3 root 2, and since this is a plus, I'll change it to minus root 3, and I'll multiply that on the top and the bottom. And I'm going to put him in parentheses also. Now I can multiply the numerators. So I'll just take 5 times each of those terms and get 15 root 2 minus 5 root 3. And on the bottom, I'm going to multiply my first terms. So remember when you multiply the numbers, 3 times 3, which is 9. And then root 2 times root 2, which would be square root of 4, which brings you back to 2. And remember, your insides and outsides always cancel each other out. So I'm just going to skip that step and multiply my last terms, which would be minus the square root of 9, or minus 3. So I just have one step left, I think. I've got 15 root 2 minus 5 root 3. And on the bottom, I have 18 minus 3, which is 15. Now, I've succeeded in getting my square root out of the bottom of the fraction. But notice here that all of these numbers are divisible by 5. So I can actually go one more step and reduce my fraction. So I'm going to divide each of those terms by 5. And so 15 divided by 5 is 3 times the square root of 2 minus 1 square root of 3 over 3. And that is my final answer. So we've finished all of the new kinds of questions that you'll be working this week. And I would like to go ahead and cross out the questions that you don't have to do, starting with lesson 64. So on lesson 64, I crossed out number 18, 21, 22, and 28, 29, and 30. Lesson 65, I crossed out 21, 22, 27, 28, 29, and 30. Lesson 66, I have crossed out 4, 5, 9, 12, and 28, and 30. And the last lesson, lesson 67, I crossed 4, 5, 23, 28, 29, and 30. So those are your lessons for this week, and I will see you next Monday.